Okay, so we're going to start day one of verifying the trig identities. However, most of the examples today are simplify. The last four are going to say factor. So we're basically doing the same thing we did Friday. We'll be looking for common denominators. We may be foiling, different things like that. We'll be doing substitution with identities. So let's look at the first example. And it says to simplify. Now, someone in the other class, no, I guess we can't do it on this one. It was a different one. All right, so we're going to go ahead and notice these are all reciprocals. Now, you can't cross simplify here because there's an addition sign, a plus sign in between each of the two fractions. So what we need to do here is we need to find a common denominator. But before I do that, I'm going to go ahead and change these to their reciprocals. So what I can do here is I'm going to work with each one separately. So let's do this one first. And I'm going to change secant into its reciprocal. But first let's remember that this fraction bar means division. So let's write this as secant x divided by cosecant x, and then now what I can do is flip it to its reciprocal. So I know secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. And now I'm dividing these. So 1 over cosine x, flip it to the reciprocal. So now I have sine x over cosine x. Now let me do the same thing over here. It's going to be cosecant x divided by secant x. Flip it to its reciprocal. Sine x, cosine x. There's plus signs in between each of these. So then keep flip change. Sine x, cosine x, and then I get cosine x over sine x. So then somebody said, well, can't we just make this tangent x plus cotangent x? I can make that simpler without an addition sign. So I'm not going to go ahead and do that for this one. I'm actually going to find a common denominator. And my common denominator here is going to be cosine x and sine x. It's going to be both of these. So let me write that on the bottom for both. And what this first fraction is missing is the sine x. So this new numerator becomes sine squared x. Over here, this one's missing the cosine x in the denominator. So whatever you multiply to the denominator, you multiply to the numerator. And now I have the same denominator under both. So now I can just add my numerators. That's a plus sign. Let me separate that a little. So sine squared x plus cosine squared x over cosine x sine x. Notice the top is an identity. It's a Pythagorean identity, and that numerator is equivalent to 1. And so I get 1 over cosine x times sine x. And then I don't want to leave my answer as a fraction, so I'm going to flip it to its reciprocal. I could actually pull these apart. And now reciprocal of cosine is secant, and reciprocal of sine is cosecant. And there's your answer. So again, it's going to get a little simpler when we know what we need to work towards. If we were working towards tangent x plus cotangent x, then that's what we would have done. However, you're going to show that it equals something and what it needs to get to. All right, so I'm going to distribute cosine x to the secant and cosine x to the cosecant. So cosine x times secant x plus cosine x times cosecant x. You're going to get to the point where you're going to realize when you multiply something by its reciprocal, that's going to become a 1. So I'm going to change my secant here into 1 over cosine. Just redrop down the cosine x. So notice when you multiply something by its reciprocal, this becomes a 1. And I can go over here, do the same thing here. Cosine x times 1 over sine x. And this becomes cosine x over sine x. I don't want to leave anything as a fraction, and this is equivalent to cotangent. At first glance, you may think, oh, this is an identity, but there's no square. I can't simplify this down anymore, so I would stop here. Okay, so potentially what's coming is you would get a question like this, and it's going to be equal to -2 secant squared x. So what I need to do is simplify that left side and make it look like the right. And I'm going to show you how we're going to get there. So this is why when we get to the 7-2b, at least you know what you're working towards and when you can stop. So for this next one, number 3, I am going to find a least common denominator. I need to find a common denominator here, and it's actually going to be both sine x minus 1, sine x plus 1. So let me go ahead and write that down here.
We did a whole chapter on this, right? Earlier in the year when there was just x.
So same denominator over here. Let me write it for the bottom of this one, and then I got to figure out what I need to do. So the first fraction, you can see that it's missing the sine x plus 1. So whatever it's missing from the denominator, you're going to also multiply it to the numerator. So this new numerator is sine x plus 1. Then over here, this one's missing the sine x minus 1. Now that I have a common denominator, I can add my numerators, or actually subtract my numerators. Now notice this subtraction sign here, it needs to go to both of the terms. So you need to distribute the negative sign to the sign and to the -1. So my new numerator is sine x plus 1, and then I distribute the negative sign to the sign and to that -1. So it turns it into a plus sign. It's got the same denominator. And I'm going to actually FOIL the denominator because it's going to turn into the difference of 2 squares. So if I FOIL the denominator, sine x times sine x becomes sine squared x. And then outside gives me plus sine x. Inside gives me negative sine x, and then last gives me -1. Notice the middle here, the blue and the green cancel. Notice in my numerator, also, I have sine x minus sine x is 0. So all I have to add in the numerator is 1 plus 1. Yes.
How did you get rid of the sine x plus 1 on the top there? How could you get rid of it if you're adding 1 to that?
It's not grouped together. I'm just getting rid of sine x minus sine x. These are 4 different terms. So I have a sine x, and then a 1, and then a negative sine x, and then another 1. So now in my denominator, I have sine squared x minus 1, which is an identity. But it's going to be a negative. So watch what I'm going to do to change the denominator. Because remember, my goal was to get it to look like this. And this numerator, sorry, is a 2. 1 plus 1. All right. So now, the identity that I'm going to use for the denominator is the sine squared x plus cosine squared x equals 1. I'm going to fix it so it looks the same. So I'm going to move the 1 over. Sine squared x minus 1 plus cosine squared x equals 0. Then I'm going to move the cosine over. So then I get sine squared x minus 1 equals negative cosine squared x. So what I'm going to replace here in the denominator is going to be negative cosine squared x. The numerator is still the 2. Remember, I was trying to make it look like this. So cosine is the reciprocal of secant. So I can just move this to the top and now make it secant. And I made it look the same. So on your quiz, you're going to make either one side, you're going to simplify it down so it makes it look like the other side. You're not going to touch one side of your equal sign. It may be the left, it may be the right. And the whole quiz is going to be showing all the steps. If you miss a step, you lose points. So you can't just jump to something. It's got to make sense logically. And again, I need to find a common denominator. So my common denominator for number 4, and I'm going to move the work down to here, is going to be sine x times 1 plus cosine x. Let me set that up for the bottom of both. It's a plus sign in between. So my first fraction is missing the 1 plus cosine x. So I'm going to distribute this cosine to the 1 and to the cosine. So the new numerator for the first fraction becomes cosine x plus cosine squared x. For my second fraction, it's missing sine x. So this new numerator is sine squared x. Now that I have a common denominator, I'm just going to write my whole numerator all together. So now I have cosine x plus cosine squared x plus sine squared x, and it's all got sine x times 1 plus cosine x. Now, sometimes I need to distribute the denominator, but right now what I'm going to do is look to see if once I simplify my numerator and combine my like terms, and maybe even do a substitution, if there's something that'll cancel with that denominator. If not, it may help me to distribute it. Notice in my numerator, if I add these two terms together, this is the Pythagorean identity that sine squared x plus cosine squared x equals 1. So I'm going to change this to a 1. And now I'm left with cosine x plus 1 in the numerator, and then the denominator has sine x, and then 1 plus cosine x. Remember, addition is commutative, so what's in the top, the cosine plus 1 and the 1 plus cosine are the same thing. These will cancel. I'm now left with 1 over sine x, and the reciprocal of sine is cosecant. So your original problem could have started out by giving you cosine x over sine x plus, is that the original problem? Yes. Over sine x, 1 plus cosine x, and it would be set equal to this. And then what you would do is you're going to draw a line. You're going to bring this thing straight down, and then you're going to show all the work that I just did for simplifying that thing to make it look like this. Notice I have a binomial squared. Now, some of you probably back in Algebra 1 might have memorized patterns for a binomial squared. If you remember from Algebra 1, whenever you have like a plus b squared, the pattern here was to square a. The middle term is a times b times 2. And then the last term is b squared. So if you know the pattern, it saves time. If not, what you can do, I notice sometimes in Algebra 1, students get confused with the patterns. So the safe way to go is to take 1 plus tan x, write it 2 times, and FOIL it. After I FOIL this, I'm going to get my answer to look like this pattern. So I'm going to do 1 times 1. That's first. Outside gives me tan x. Inside tan x times 1 is another tan x. And then finally last gives me tan squared x. Notice when I add the 2 in the middle, this gives me the 2 tan x. So then my 1 here, and then my plus tan squared x. Notice it's the same type of pattern. I squared my first term, I multiplied the 2 things together, and then I times it by 2, and then squared the last one. Now I still also have, from my original problem, this thing. Let me add this to the end. And now I'm going to look for like terms. So notice the 2 tan x and the minus 2 tan x are going to cancel. It becomes 0. And now I'm left with 1 plus tangent squared x. And this is actually an identity. So my final answer equals secant squared x. Next one, I have to FOIL both sides. We're gonna FOIL this side, and we're gonna FOIL this side. Or we could also do the pattern that I just showed you. So the pattern for the left side, I square tangent x, and then the middle term is gonna be this times 2. So 2 tan x cotangent x. Now, keep in mind, you can also do this, tan x plus cotangent x, and then FOIL it if you prefer to do that. Just taking a shortcut here. And then cotangent squared x. Now I got to do the blue side. Now, also keep in mind, you've got a subtraction sign in between here. So after I FOIL this or do the trick, I'm going to have to distribute that subtraction sign to all the terms that I get. So tangent squared x, middle term is going to be negative 2 tan x cotangent x, and then last will be plus cotangent squared x. So now I'm going to distribute this sign to all 3 things. So let me rewrite my red. So it's tangent squared x plus 2 tangent x cotangent x plus cotangent squared x. Now I'm going to distribute the sign to all the blue. So negative tangent squared x plus 2 tangent x cotangent x, and then minus cotangent squared x. Now I'm going to look for like terms to combine. So tangent squared x minus tangent squared x is gone, and the same thing for the cotangent. So now I do have 2 like terms here, and this will become 4 tangent x cotangent x. Notice I'm multiplying something by its reciprocal. So that's going to become a 1. So 4 tan x times the reciprocal, which is 1 over tan x. Notice these simplify, become 1s. So my final answer here is 4. Notice this is the difference of two perfect squares. So if I just square root both sides, I end up with secant x plus 1 and secant x minus 1. And I'm done. So when it says to factor, that's all you do. So again, what you could do is take out this secant and you could make it x squared minus 1. And then just remember it'll be x plus 1, x minus 1. But just remember to put x back as secant.
We're gonna have to do like the 5 one.
All right, so for number 8, if it's easier for you to think of this as 4x squared plus x plus 3, factor that and then put back in the word tan. You can do that. So if you're going to do guess and test, you would do the factors of 4 and the factors of 3. That would give you the answer, or you could do factor by grouping. I'll just guess and test because 4 and 3 are small enough. So factors of 4 are either 4 times 1 or 2 times 2. I'm going to do 4 and 1. So 4 tangent and 1 tangent. And then my factors of 3, to make a negative 3, I need to, let's see this. I put negative 3, positive 1. So if I FOIL this, one way you can do this if you're going to guess and test is you have to FOIL it and check it. Let's check. So if I do first, I get the 4 tangent squared x. Outside gives me plus 4 tan x. I need an x here. 4 tan x. Inside gives me minus 3 tan x. And then last gives me minus 3. Notice when I add the middle here, I only get 1 tan x, which is what I was trying to get. So I did pick the correct binomials, so my final answer is right here. So it's 4 tan x minus 3 and tan x plus 1. Tan x plus 1. So I'm going to do cotangent squared x, cotangent squared x. That's the beginning. And then the factors of 2 are just 1 times 2. It doesn't matter if I put plus 2 first or plus 1 first. And that will FOIL back.
Can that continue going though?
No, all the instructions here say to do is factor. So when it says factor, this is all we're doing. The last one is a cube pattern. Yeah, let's remember our SOAP pattern. So remember when it was a cubed plus b cubed, we cubed root a and b. So same sign, opposite, and then always positive. So SOAP. And this would become b squared. So in my problem here, my a is sine, my b is cosine. So I'm going to do sine x plus cosine x, square the sine, flip the sign, opposite, multiply sine x cosine x, and then always positive. Square the cosine. And it would be factored. Now, I can simplify this down. On this one, I'm going to use my commutative property, and I'm going to flip-flop these two. So I'm going to put sine squared x plus cosine squared x minus sine x cosine x. Let me rewrite this. This simplifies to a 1. So then I get sine x plus cosine x times 1 minus sine x cosine x. And that would be that one factored. When you're doing the 7-2A homework, some of the instructions say simplify, some say factor. So when they say factor, look for difference of two squares, maybe some are difference of cubes, maybe just a simple trinomial that you have to factor. So the 7-2A homework, I'll go back to that one. That was it. That was is 1 through 31 odd. But this is due on Wednesday. Last one.